Hey guys, Mr. Harper Smith here. So today we're not talking about slope, because remember for IB they don't ever use the word slope. We will be talking about gradient. Okay, finding the gradient of tangent lines and tangent curves. So first off, let's talk about what is gradient, how do we find it? Gradient is a way to measure the rate of change between 2 points. Okay, so if we have 2 points, 4, 2, and 10, 5, and there's a line going through them, at what rate is the line changing? Well, if we remember, there's a small little formula. It's y2 minus y1 over x2 minus x1. That gives us our gradient. You might want to write that down. Okay, so your y2 is 5 minus our y1 is 2 all over 10 minus 4. And that's going to spit out 3 over 6, which is going to equal 1/2. That is the gradient, or the rate of change, for the line. How would I write that in point gradient form? So the line here, how do I write the equation for the line? Well, the equation for a line is y minus y1 equals mx minus x1. So you can pick whichever point you want. You can use this point or this point, and we plug it into the equation. Okay. For this case, let's use y2 and x2 for these 2 points. So y2 is 5. So y minus 5 equals 1/2 x minus 10. Okay? There you go. That is the equation of the line. Now I would have got the same thing if I would have used 2 and 4 instead. So 2 here and 4 there. Okay? Would have been the same exact thing. Sorry. 2 and 4. Would have been the same exact thing. Okay? All right. So basically, anywhere along this line, the gradient is 1/2. Everywhere along that line. While finding a gradient when the line is straight is really easy, it can be really tricky to find the gradient when the line is not straight. Okay, so here we have a parabola. Finding the slope, the gradient, well, isn't it constantly changing? I mean, here the gradient is going to be flat. Over here it's going to be angled down. Over here it's going to be angled up. So we can find the gradient at specific points on the line. Okay? So right here, for instance, we can find the slope or gradient, how steep it is, if we draw a red line. Okay? A tangent line is what we call this. A tangent line is a line that is perfectly parallel to the parabola at a certain point. If you notice, it's not parallel to that point. It's not parallel to that point, but it is parallel right there. In fact, it's actually touching. Okay? So it's touching right there at the point 1, 1. But we don't know what the gradient is. We don't know how to write out the equation. So if I'm going to figure out the equation of that red tangent line, I first have to figure out my gradient. Okay? Remember, gradient is y2 minus y1 over x2 minus x1. That's how I find my gradient. Now, we're looking at this and we're thinking, oh, heck, how do I do that? There's only 1 point. Well, what if we found 2 points? Bear with me for just a second. What if we look, this is, 1, 2 right here. What if we look at 1.9 and 2.1, okay? So right there and right there. Are those going to be pretty dang close to what the red line slope is? Absolutely. It's going to be very, very close. So what I need to do is I need to figure out what are my y values at 1.9 and at 2.1. There's a couple different ways to do this. My favorite way is to graph the line. So I'm going to graph the blue line. Okay, I've got my handy-dandy calculator. I go to y equals, if you have a TI Nspire, you can use your TI Nspire as well, x squared minus 2x plus 1. Okay, so I just I've got it in there. I'm going to hit trace. Bloop, goes down, comes up. Now, I want to know what is my y value when I'm at 1.9. So I type 1.9. Remember, I'm on trace. I get 0.81. So I've got 2 points. One of my points is 1.9, comma, 0.81. Okay, there's 1 point. Now the other point I need is 2.1. Now you can go a little bit crazier even if you want. So we can go 2.01, because the closer and closer and closer we get these 2 points to that 2 value, the 2.1, the closer these 2 points are, the more accurate our tangent line is going to be. I'm going to use 2.1 though, okay, so just 2.1, that's all that I'm using. I get 2.1 comma 1.21, all right? I have 2 points. Can I find my gradient? Absolutely, absolutely I can. So I take these, I plug them in. That gives me 1.21 minus 0.81 over 2.1 minus 0.19. Sorry, 1.9. It's going to give me what? 0.4 divided by 2.1 minus 1.9. And I get a perfect 2. Okay. So my gradient right here isn't 1, it's 2. It's a little bit steeper than being a 45-degree angle. So when I go through and I write the equation for the tangent line, what is the gradient? Gradient is 2. Well, when I go through and I write the equation for the tangent line, I've got y minus, this is the 0.21, I'm sorry. So y minus 1 equals 2x minus 2. That is the equation for this red tangent line exactly at that point, where it touches and it's perfectly parallel at that point, okay? It's perfectly parallel at that point, and then it keeps going up, okay? That is the equation for that line. Okay, let's look at another example. So here we have another parabola. Don't judge me because it's not a perfect parabola, okay? I drew it freehand. I'm not perfect at drawing. But let's find the tangent line at the point -4, 4, -4. Okay? Let's figure out what is the equation of this red tangent line at that point. Well, we already have, if we're going to use point slope form, or point gradient form, we already have the point that we're going to use. The only thing we have to figure out really is what is the gradient at this point? What is the gradient? What is the slope, right? Is it going to be 4? Is it going to be 2? Is it going to be 3? I don't know. That's what we're about ready to find out. So let's see here. We've got we need to figure out 2 points that are really close to this 4, -4. So we can come up a little bit and then down the same distance. All right. So if we're coming over just a little bit from 4, maybe this is going to be like 4.1 something. Then over here we're going to have 3.9, comma, whatever the y value is. Well, I'm going to use my calculator. I'm going to type in x squared minus 4x minus 4. Well, it might help if I type that right. Minus 4x minus 4. Okay, that's what it gives me for a graph. Well, if I'm going to figure out what is it at 4.1, I just typed in 4.1. At 4.1, my y value is negative 3.59. So negative 3.59. And when I do 3.9, I get a y value of negative 4.39. Okay. Probably just do 2 decimal places or 1 decimal place. You don't have to get too crazy there. So when we go through and find our gradient, remember the equation for gradient is y2 minus y1 over x2 minus x1. That's going to give me, let's see here, negative 3.59, 4.1 minus negative 4.39 over 3.9. Okay, let's go through and do some math. I'm going to type that into a calculator, figure out what my m is. 3.59 minus negative 4.39 divided by 4.1 minus 3.9. Gives me a perfect 4. That is my gradient, okay? I'm actually going to write that over there. Okay. So 4 is pretty steep, all right? 4 is pretty steep. We had 2 on our last gradient. Now we've got a 4. So my last step to figure out the tangent line equation would be to just use the point gradient equation. So that would be, if we're using this point that we're originally talking about, the point that's on the blue line, the red line is touching, it's going to be y plus 4, because minusing a negative gives me a positive, equals 4x minus 4, okay? That is the equation for this line here, for the red line. Now, if you want that in y equals mx plus b form, what you would do is you distribute your 4, then you would minus 4 from both sides. Minus 4, that would give you y equals 4x, negative 14 minus 4 would be negative 20. So if I asked you, hey, where does this tangent line cross the y-axis? Crosses at negative 20. Okay. Now, this gradient of 4 is only at this point right here. The second you start getting up higher, the gradient's going to get larger, bigger. As you start moving down more, I mean right here, that's flat. Okay? If it's flat, the gradient's not 4, the gradient's 0. Right there at the very bottom, the gradient's going to be 0. It's only right at this one point that we figured out what the gradient is. All right, on this one, I want you to try it on your own. What is the equation of this red tangent line? The equation is 2x squared minus 2. The point that we are looking at is the point negative 1, 0. Okay, take a moment, try to figure out what the tangent line equation is. Pause the video if you have to. Okay, here we go. Here's the answer. So we first need to figure out 2 points that are extremely close, because we need 2 points to be able to make this tangent line. The closer they are, the better. So up till now we've been going like 4.1, 3.9, 1.1, 0.9, 2.1, 1.9. We can go even further than that though, okay? We could go, let's see, this is negative 1, so we could do negative 0.999 if we want. So I've got 3 9s there. Here I could do negative 1.001 if I want to get really crazy, okay? That's my x value. Now I'm about ready to figure out my y value. Should have written that one a little bit different. See, negative 1.001 is my x. Let's figure out the y. We're going to figure out the y there as well. I'm going to grab my handy dandy calculator. And I've got, let's see here, 2x squared minus 2. That's how I'm typing it in. I hit the trace button. Oh, I did something wrong. Oh, that's what I did wrong. Huh, I got rid of the x. Silly me. Okay, I hit the trace button. That's a little better. That's roughly what it should look like. So I'm going to do negative 0.999. It gives me 0.003998. Whew. So we've got the point. I'm not even, yeah, okay. Negative 0.003998. You can go as many decimals as you want. The more decimals you go, obviously, the more accurate it's going to be. 0.001 is my, negative 0.0. And 1.001, I get 0.004002. I'll exit out of that. I'm now going to try to plug it into my equation. It's y2 minus y1, so negative 0.003998 minus whatever over negative 0.999 minus, look at the other one, 0.004002 and negative 1.001. Okay. Whew. That's a lot. As you can see, as you start to add more decimals, it does make it a little bit crazier. All right, let's see here. We've got negative 0.003998 minus 0.004002 divided by negative 0.999 minus negative 1.001. And that gives me a slope of negative 4. Exactly. Okay. Some of you that didn't go as crazy with your decimals, you probably got the same exact number. Hey, imagine that. You should be getting, if you didn't get negative 4, if you got something totally different, you probably did something wrong. Okay. Negative 4 is our gradient. Well, we've got a gradient. We have a point, negative 1, 0. All it's left to do is use the point gradient equation. So here we go. It is y minus our y value, which is 0, equals m, which is negative 4, x minus negative 1. So that's plus 1. Okay. If I asked you, where does this cross the y-axis? Okay. So if we follow this red line down, where does it cross? Should be about negative 4. Sure enough, if we go through distribute, it gives me negative 4x minus 4. We did it right.